Hi, I'm Simon, lead engineer at NetFabric. In this video, I'll show you how NetFabric can help you identify forwarding problems in your network. But before we start, let me quickly introduce NetFabric. At NetFabric, we're building an intelligence engine that understands your network. We focus on 5 areas: get visibility, prioritize, connect, predict, and innovate. All of these save time in key parts of your network operations. Today, you'll see how NetFabric monitors the health of your network and reliably detects forwarding problems. When network performance is bad, it can be hard to tell where in the network the problem originates. To get to the source of the problem, we need to find the routers and links that do not forward traffic as they should, like links experiencing packet loss. However, this detection must not generate false alarms. Otherwise, spotting the truly problematic devices becomes impractical. Let me now show you how NetFabric monitors the health of your network. Let's start from this example customer ticket. This ticket complains about the connectivity to a backup server with the URL backups.example.net. Let's assume that level 1 support attached some basic insights to the ticket already. Here we see the IP of the backup server at backups.example.net. For this destination IP address, NetFabric has found 2 path changes, which are discussed in our demo on path changes, linked in the video description. In this demo, we will look directly at the unhealthy path that was found. At the top of this dashboard, we see an overview of the network. In this network, there are 2 network components that are connected via tunnels over the public internet. NetFabric understands various kinds of tunnels, such as MPLS tunnels, GRE tunnels, and 6x4 tunnels. Moreover, NetFabric also understands other advanced routing concepts, such as OSPF areas. In the main panel, we also see the path used by the flow to the backup server. Most interestingly, we see that the flow traversed a tunnel edge that is highlighted with a red dashed line. The red dashed line means that there were network health alerts related to the tunnel edge. So NetFabric detected that this tunnel experienced problems when forwarding traffic. Now, what does this network health actually mean? To judge link health, NetFabric looks for so-called discrepancies in packet counters. That means we take the number of packets that go into the link at one end and compare it to the number of packets that come out of the link at the other end at roughly the same time. If these numbers do not match, there is likely a problem with the link. For example, if more packets go into the link than come out of the link suffers from packet loss. In our case, such discrepancies were observed for the tunnel edge E40. So most likely, it is this edge that is causing our connectivity issues. In this case, we can conclude that the connectivity issue does not come from the internal network, but from a tunnel over the public internet. You could thus contact the provider of that tunnel. Importantly, the fast resolution that we have seen here only works if we can quickly detect truly unhealthy links, and if we are not distracted by false alarms. Let's see how NetFabric achieves this behind the scenes by investigating the critical tunnel edge E40. In this dashboard, we now see all the alarming packet counter discrepancies that were found for the tunnel edge. A positive value, such as 1643 on the first discrepancy, means that 1643 more packets were sent into the tunnel than were received at the other end during a given time period. This number of missing packets is considered alarming. To better visualize this discrepancy, let's look more closely at it. At the top of this new dashboard, we see the raw data for the packet counters over time. In blue, we have the egress packet counter of the router at one end of the link. In yellow, we have the ingress packet counter of the router at the remote end of the link. Here, we already see that the remote ingress packet counter is often substantially below the egress packet counter. This means that considerably fewer packets arrived than were sent. This indicates some form of packet loss. However, neither router reported packet drops. The packet discards are consistently 0, as shown by the red flat line in the panel at the top. Why is that? In fact, the routers would only report packet drops if packets were dropped on the physical link that is directly attached to the router. However, our edge here is a tunnel that crosses the public internet. Therefore, packets are dropped somewhere else along the way. These packet drops are invisible to the packet drop counters that are available to us. Packet drops may also be invisible in other hybrid network setups, such as in the cloud or in case of malfunctioning hardware. That underlines why it is important to compare egress and ingress counters rather than just relying on packet drop counters. The discrepancy in question happened in the 5-minute time interval that is highlighted in orange. In that interval, more packets were observed on the egress than on the ingress. Crucially, how we calculate the number of packets in this interval makes a huge difference on whether we generate false alerts. Specifically, false alerts can occur because packet counts from different devices cannot be compared directly. This is because they are typically collected at different times and using different clocks. To avoid false alarms, we use an intelligent aggregation correcting for these issues. We achieve this by means of mathematical techniques such as interpolation and correlation maximization. In this case, the result of this intelligent aggregation is that considerably fewer packets are received than are sent, which reflects the raw data well. To see how valuable the NetFabric intelligent aggregation is, let's compare this intelligent aggregation to a much more naive form of aggregation. For the sake of this demo, we included the basic aggregation. In this basic aggregation, we compute the number of packets in an interval in the most straightforward manner. Specifically, we check the cumulative packet counter at the end of the interval and subtract the counter just before the interval. In this case, the result of this basic aggregation matches the result of the intelligent aggregation. More packets are sent than received. However, this basic aggregation is highly prone to generate false alerts. Often, the basic aggregation reports a large discrepancy for a link, even when the link had no problem. These false alerts are especially common in the presence of traffic bursts. Indeed, using the basic aggregation by default generates a ton of false alarms. To see these false alarms for our network, let's diagnose the network health with the basic aggregation. As we see, many more edges are now red and dashed. This means that many more health alerts are raised on many more edges. This flood of alerts is tough to handle. Even worse, the alert relating to the tunnel edge E40, so the alert seen before, has now vanished. This is because the packet counter discrepancies on that edge do not look anomalous anymore in the flood of large discrepancies. So, the network health alerts generated by the basic aggregation are unreliable. To see how the basic aggregation is fooled, let's look more closely at the alerts for a single edge again. Here we again have the overview of packet count discrepancies relating to the edge. So let's again look at one discrepancy more closely. Here we again have the same discrepancy overview as before. Here, however, we see that the basic aggregation indicates a large discrepancy between the egress and ingress packet counts. In contrast, the NetFabric intelligent aggregation does not indicate a discrepancy. This properly reflects the raw data. From the raw data, we can verify that there is indeed no real discrepancy in packet counts. In fact, the packet counts only slightly differ in their reporting times, which fools the basic aggregation. The best thing, the NetFabric network health monitoring, is just the beginning. NetFabric is packed with tools that bring intelligence to your network. To learn more or get in touch, go to netfabric.ai or send us an email. Links are in the description.